So really yesterday made up the toughest part of this whole unit, and the idea of what a subprogram is, and how to use it, where to use it, when to use it, why to use it, all the big nitty gritties. Today we're just going to expand upon what we already know. We're just going to create another type of stamp. So yesterday the stamp just simply did a job. Today we're going to expand that. Today we're going to talk about functions, the second type of subprograms. And just like yesterday, this one is meant to be viewed in presentation mode, so download it and open it on your computer before you try and actually look at the PowerPoint itself. So again, just like yesterday, same objective. Today we're going to learn about functions, what they are, how to define them, and how to use them. Yesterday we talked about the fact that there are two types of subprograms or methods, procedures and functions. We did procedures yesterday. Today is those functions. All right. So let's get right into it. Now, if you remember yesterday, the definition of procedure was a mini program within a program that performs a single task. Full stop, right there. A mini program within a program that performs a single task. All we're doing is adding one extra piece to this for functions today. So a function is a mini program within a program that performs a single task and returns a result to the programmer. Notice that it's going to the programmer there, not to the user, to the programmer. It's then the programmer's job to do something with that information. Now, we've already seen examples of this: pow, squirt, square root, read line. All of those things give us a value back, every single one of them. And we always did something with that value. Maybe we applied it to a further calculation. Maybe we stored it in a variable for use later on. It depends, but we did something with that data right away. And that's what we're going to today. So let's take a look at the general syntax to create a function. You're going to see one good thing is the fact that it's almost identical to a procedure with two small differences. So again, yellow is customizable. Blue is the only different things from yesterday to today. So we still start with private static because it's still something that we're defining outside of the main method. Now, instead of the word void, we now have return type. We'll get into that in just a moment, what that actually means. We're still got to give an identifier. We still have to list off all of our parameters. We still have code that's going to be executed from top to bottom. But then finally, we're going to have a return statement. And as it says here, our functions return a result. So that's what this last statement does. It returns a value back to the programmer. The key thing here is that that value must match the same type as the return type. So the return type defines what kind of data we're giving back to the programmer. The return statement says, what is that data? That's it. Let's look at an example. So here's one that calculates the area of a wall. Private static double calc wall area. It has two parameters, length and width. Well, I'm calculating a wall, which is a rectangle, so I need a length and a width. You'll notice that there's not an area variable there, and that's because area is not coming in. Parameters are for data that's coming in to do the job. I can't bring area into the subprogram because that wouldn't make any sense, because why would I need the subprogram if I've already got the area? That's not what it's for. Parameters are for data coming in to do the job. That's key here. So we have double, which is our return type, calc wall area, which is our identifier, and then two parameters that are needed to actually calculate the area of that wall. Inside, we have three simple lines of code that do the work. First, we're going to define a variable to actually store the calculated value. You'll notice that that variable has the exact same type as our return type. They're both doubles. So I said double area. Then I do the work. Area equals length times width. Well, that's the formula for the area of a rectangle. Easy peasy. And then our final statement, return that area. All that does is it sends it back to the main program. Whoever called calc wall area is now going to get that area in whatever value it is. We don't know what its value is because it depends on what values were given to length and width. We'll figure out how that works in a second. So let's break this down so we can see everything. So just like yesterday, we have the same setup. We have static, which is required because it's created outside the main. We have our return type. This is one of the differences. Our return type, this time it's a double. It's not void. This tells C# that this is a function, not a procedure. Procedures don't have a return type, hence void. Void means nothing. In fact, it means less than nothing. It is an empty nothingness. And then we have our identifier, which has the same rules as yesterday. Mixed case must describe the purpose. Any parameters that are needed to do the job. Well, I'm calculating the area of a wall, so I need length and width in this case. The code that's actually going to do the work. And then we have our, where do we go? That arrow, yeah, that's fine. Oops. So notice area is a local variable defined inside of calc wall area. So what does that mean? That means when we get to that closing bracket, not only will length and width be deleted, so will area. Those are all three local variables to calc wall area. And then it is not a parameter. It's not a parameter because, quite frankly, it's not needed data to do the job. It's what's being done. Okay? All right. So now that we know what all these things are, well, how do we actually use it? We still define them in the same place as we define procedures. They still go below the main method. Okay? So how do we actually use it? Well, we use it the exact same way we did a procedure. We just call it by its name. The difference is, though, is that this one gives us a value back, which means we need a variable to store that value. Just like when you got data from the user, you would call console.readLine. Well, if you didn't store the value that the console.readLine gave you, you lost it. So it's important that you create that variable to actually store it. And of course, that variable needs to be the same type that's being returned back from the function. So let's take a look at that. We're going to do it in two ways, just like yesterday. We're going to start by sending in literal data for parameters, and then we're going to do the same thing with variables for the parameters. All right. So first up, what we're looking at here is literal values. Now, what actually happens here? So we have our class main. Where's my pencil? We're going to use my pencil again today. And we got our pen. What color did we get here today? We'll use green. Okay. So we have almost the exact same code as yesterday, except a little bit more detailed. We have our main method, which is going to call our calc wall area function. You'll notice that it has a variable called wall area, and that's where this is being stored in. All right. So once calc wall area is done, it's going to get a value back. And we're going to store it into the wall area variable. If we don't do that, we've lost the data. Down in the actual work, this is just the same subprogram that we just wrote on the previous slide. Right? So we have our return type, we have our return call. You notice there's a space in between there, and we have our parameters. Okay, let's take a look at this. Oops, getting a little excited on here. So first thing that's going to happen is we're going to come in here and it's going to define a variable called wall area. We have wall area. Okay. And then it's going to go down onto the next line, and it doesn't do the left-hand side of the equal sign yet because it has to finish the right-hand side. So it's going to see this. It's going to jump down into our signature line of our function. It's going to come across. It's going to say, oh, I need to define two variables, one called length and one called width. Well, what are the values of those things? Well, it copies this 2.5 into length, and it copies this 2 into width. So 2.5 goes into length, and 2 goes into width. It comes inside of the program now. It says, oh, I need another variable. This one is called area. Okay, doesn't have a value yet though. And then it calculates area. 2.5 times 2, which of course is 5, and then it takes that number and it stores it inside the area variable. So now area has the value 5. And now the next piece, we get to this return area command. It is a command because it's got a semicolon. So what's going to happen with this is it's going to return it all the way back up to calc wall area, which is then going to say, hey, assign it into wall area. So it's going to take the 5 and it's going to assign it into this variable called wall area. All at this point, delete. I need to change my color of my pencil here. Red here. Yeah. So it's going to say delete, delete, delete. All three of those get deleted. So the only thing left in memory at the end of this is the wall area variable. And then it gets displayed on the screen. Wall area 5. That's the entire outlook. We saw four variables being defined, and then the final one was wall area. That was the only thing left in there. Then after that console.writeLine command, we get to the closing bracket of the main, and guess what? Wall area gets deleted too, because the program's done. We're all done. So we're all said and done. RAM has nothing left in it. We've cleared it out. So this is using literal values, 2.5 and 2. So it just copies these literal values into the parameters, just like we did last time, 2.5 into length, 2 into width. It does the work. It returns it back, which is then stored into the variable on the left-hand side of the equal sign. So what you can see from this is that the entire function will execute to completion before trying to assign the value into the variable. Okay, so that's all fine and dandy when you are talking about literal values, but does it change much for when we're going to pass in variables? No, it doesn't. You saw it in the procedures. It basically does the exact same thing. The only difference is that there's going to be a couple extra variables to maintain that wall length and the wall width. Well, they don't actually get affected because only copies of their data are passed into length and width. So let's take a look at that. We have the exact same setup here. The only difference is instead of setting wall length and wall, or instead of just calling 2.5 and 2 inside of here, instead of just saying, hey, you're 2.5, oops, I don't want to write like that. Instead of just saying 2.5 and 2, we just retrieve this data from the user. We don't know what they're going to type in, but we don't care as long as it's valid. And then it's going to get passed in, and the data is going to get copied from wall length into length and wall width into width. And then it's going to execute the exact same way as before. We don't know what they're typing in, and it doesn't really matter. So let's say they typed in, oops, where did my pen go? Here we go. Let's say they typed in, I don't know, let's say 7.5 and a 3. So 7.5 and a 3, so that 7.5 is then going to get copied, and the 3 is going to get copied into here. Now, these variables, if I wrote this line of code here, length equals length plus 2, well, that would make length now 7.5. So length is now 15, not 7.5. Right? Length is now 15 plus 2 times 2 times 2. So I make that 15. Well, what happens to the wall length variable? Nothing. Absolutely nothing. We didn't change it. We didn't touch it. We didn't even think about touching it. We changed the length variable, which has nothing to do with wall length. So it's its own variable. So then we do this code, and length, since now length is 15, we do 15 times 3. So area would have the value 45. So 45, which would then get passed back up into here, which then gets stored into there. So wall area would have a value of 45. So you can see the difference here. You can also see what I showed you, that if we modify our parameter, it does not affect any external variables at all. Because again, copies. I can't say that enough. Okay, that's it. So procedures do a single task, functions do a single task, and return a result to the programmer. If you have that and you realize that you got to store that result so you then can use it later on, maybe in this case it's just displayed on the screen, but if you remember our example way back when we were calculating how much it cost to paint a wall, you would then use this wall area to calculate more information in terms of like the paint cost and things like that. So that's it for variables and functions. Moving on, we're almost at we're at a good point. We're past the halfway point of the course now.